Hi everyone, and welcome back to the channel. Today we're exploring an idea as fascinating as it is mind-bending. Let's start with a real provocation. What if the reality we live in were just a projection? A true holographic three-dimensional hologram generated by a two-dimensional cosmic film? Seems science fiction, eh? Yet it's a solid scientific theory, gaining increasing recognition in the scientific community. The Holographic Universe theory. Let's explore it together. But buckle up, because this won't be a short trip. It will be a full immersion that, I'm sure, will leave you speechless. Stay tuned till the end, you won't regret it. But let's start from the basics. What is a hologram? A hologram is an instrument capable of recording both the amplitude and the phase of light waves, allowing it to generate three-dimensional images with depth and perspective. The secret is interference, a single laser beam which is divided into two separate beams by an optical splitter. One beam, called the object beam, illuminates the object, carrying with it all the three-dimensional information of the object itself. The other, called the reference beam, is directed directly onto the holographic plate. When the two beams meet and overlap on the plate, they create an interference pattern that is the three-dimensional imprint of the object. Just illuminate the plate with a laser beam and the three-dimensional image of the object materializes. The most surprising characteristic of holograms is the non-locality of information. If you cut a hologram into pieces, each single piece still contains the entire original image. This idea that every part contains the whole is fundamental to understanding how this theory extends far beyond a simple visual effect. And in fact, now let's try to extend this concept to our brain. Neuroscientist Carl Pribram, with physicist David Bohm, proposed the holonomic brain theory, which suggests that the brain functions holographically. The starting point was the non-localization of memory. Pioneering experiments by Carl Lashley and Pribram demonstrated that memories are not stored in a specific area of the brain. Even by surgically removing large portions of the cerebral cortex, specific memories were not erased, but remained surprisingly available. This suggested that memories are distributed across an entire neural network, just like in a hologram, where every fragment contains the information of the entire image. Further animal experiments have further supported this idea. Pribram trained rats or monkeys on specific tasks and then surgically removed various sections of their cerebral cortex. He observed that, despite the lesions, memories were never completely destroyed, and the ability to recall only decreased based on the amount of tissue removed, not its specific position. This evidence provided an empirical basis for the idea that the brain functions like a hologram, distributing information so that every part contains the whole. More recent research has also explored how this interpretation can explain photographic memories. If memory is distributed in a complex holographic pattern that can be reconstructed, just like it happens with a hologram, then the ability to recall images, texts, or information with extraordinary detail could be explained as a form of reading or decoding of this holographic pattern. But now let's push even further. If the brain is holographic, is the universe? According to the holographic principle, the answer is yes, given that our three-dimensional reality could represent a projection from a two-dimensional surface. The idea stems from the thermodynamics of black holes. Jacob Bekenstein discovered that the maximum entropy of a black hole is proportional to its surface area, called the event horizon, and not its volume. This implies that all the information of matter fallen into the black hole is encoded on its horizon, which is a two-dimensional surface. Then came Stephen Hawking, who showed that black holes emit thermal background radiation, but it does not contain information about the matter that fell inside. So if a black hole completely evaporates, emitting only radiation, the original information would disappear forever from the universe, violating a fundamental principle of quantum mechanics and creating the so-called black hole information paradox. The holographic principle offers a solution. Information is not lost, but is conserved on the event horizon, just like in a hologram. Temporal dilation, caused by the immense gravity of the black hole, stops time at the event horizon, imprinting the information there. The cosmic holographic theory was further supported by Juan Maldacena, a renowned Argentine physicist and professor. With a mathematical relationship, he demonstrated that all the information of a three-dimensional universe, which also includes gravity, can be described and encoded in a two-dimensional representation. This would support the idea that our 3D universe is a detailed projection of incised data on a distant 2D surface, and would offer a concrete way to unite gravity, general relativity, and quantum mechanics. In this holographic context, Fourier transforms are a key mathematical tool. Imagine them as a universal translator for waves. They allow us to convert the shapes we see in space into wave frequencies and vice versa. This is fundamental because holographic theory suggests that reality at a deep level is made of quantum vibrations and resonances. The holographic model can therefore rely on solid mathematical support, which helps us understand how information spreads and is then reconstructed, both in the brain and in the universe. But then, if the brain and the universe are holographic, what are the implications? Well, the consequences are enormous. This perspective suggests that reality is a vast interconnected network of energy and information, where every part reflects the whole. This implies that space and time might not be fundamental, but emergent phenomena from encoded information. Information, not matter or energy, could be the fundamental building block of the universe. And consciousness? In a holographic universe, consciousness is not limited by space or time and is not reduced to just the physical brain. It is theorized rather as a fundamental field, capable of influencing or even creating observed phenomena. By aligning thoughts and emotions, we might even be able to influence the quantum field to manifest desired reality. The brain would act as a receiver of states of consciousness from a universal field. This vision connects to other revolutionary ideas that unite consciousness and quantum physics, like David Bohm's implicate order or Penrose Hameroff's orchestrated objective reduction. I've delved into these topics and the general connection between consciousness and quantum physics in an overlapping way. Don't miss it if you want to know more. This theory could offer a scientific perspective to interpret near-death experiences or cases of reincarnation, suggesting the potential survival of consciousness after the death of the physical body. The scientific community remains divided. Strong experimental findings to demonstrate the theory are still being sought. But more and more renowned scientists are actively contributing to its development. This vision leaves us with profound questions. If our reality is a hologram, what role do we, as conscious beings, play in this grandiose cosmic projection? If this journey has fascinated you, leave a like and especially subscribe to the channel so you don't miss the next videos. See you at the next video, always at the frontiers of science.